The Hansen Ranch is a site of one of the richest dinosaur bone beds in the world, with documented remains of potentially thousands of dinosaurs. The bone bed is nearly a meter thick and stretches over many square miles. The story of how the Hansen family ranch came to include a research station and a dino dig is a fascinating one.
We became aware at an early age, and I can't tell you just how early, because we've always taken dinosaur bones for granted. Wherever we were walking or running or hiking or riding a horse, there were areas where you could recognize vertebrae and things like, that were recognizable even to us, as children, and my dad would point them out. And we would pick them up and look at them and many times just throw them down again because they were so numerous, and because we just, thought everybody in the world must have dinosaur bones. They're everywhere here.
In 1993, a professor of paleontology became very interested in the bones that were lying on the surface of the ground at Glenn Hansen's ranch in a remote area of eastern Wyoming. The bones had come from the Lance Formation and were just 2 miles from where the first Tyrannosaurus rex skeleton had been discovered.
With Mr. Hansen's permission, the paleontologist opened up several quarries where he and his students began digging. He named the site Dragon's Grave Bone Bed. When he discovered the wealth of fossils in the site, he wanted to build a field station for teaching and research. So, he requested a 99-year lease for the site.
But Mr. Hansen was troubled that the students were only being taught an evolutionary interpretation of the fossils on his ranch. He agreed to sign the lease, but with one stipulation, that the students be taught the creationist perspective in addition to the evolutionary interpretation.
To the paleontologist, teaching creationism was like teaching mythology, which he refused to do. "This is the last day that real science will ever be done on Hansen Ranch," was written on the side of a storage shed as they left, never to return.
Glenn Hansen wanted creationists to study the dinosaur fossils on his ranch, and was determined that creationist research be done using the highest scientific standards. He needed to find a qualified vertebrate paleontologist who was committed to a biblical worldview. He contacted the Institute of Creation Research, who referred him to Dr. Lee Spencer and Dr. Kurt Wise.
Mr. Hansen invited them out to the ranch, where they gave recommendations on how to do effective research at the site. Following their advice, the Hansen Research Station was set up as a nonprofit organization with a scientific advisory board to ensure that the highest quality paleontological research would be done.
Since Dr. Wise was unable to be a part of the actual research project, Dr. Spencer contacted Dr. Art Chadwick, a geologist at Southwestern Adventist University who had a strong interest in creationist research. Together, they formulated a research proposal that was approved by the Hansen Research Station Board, and the Dino Dig was born.
The Dinosaur Project is a long-term research plan to excavate the fossilized remains of dinosaurs and other creatures. An important aspect of the project is to conduct careful scientific research about the taxonomy of the fossils. Taxonomy is the study of processes such as decay, transport, burial, and fossilization of dead organisms, and gives clues about what happened to the animals when they died.
Another goal of the Dinosaur Project is to provide exciting quarry experience and the joy of discovery for students, teachers, and dinosaur enthusiasts. College credit for a course on dinosaurs is also available.
Since the first Dino Dig in 1997, professional paleontologists, along with a host of volunteers, have spent the month of June at the Hansen Research Station excavating fossils.
From the early years, when just a few volunteers excavated less than 100 fossils per season, the Dinosaur Project has grown to have nearly 100 volunteers, excavating well over 1,000 fossils per season. In 2013, the 15,000th fossil was discovered. Volunteers who often return year after year include people of many ages who want the thrill of digging out ancient fossils.
Lots of bones and teeth from Upper Cretaceous dinosaurs like Edmontosaurus, Triceratops, and Tyrannosaurus, mixed with fossils from sharks and rays, alligators and crocodiles, mollusks and plants. The remains are disarticulated, which means they are all jumbled together rather than being deposited as an intact skeleton. The bones are buried in a single graded bed with larger bones near the bottom and progressively smaller bones near the top.
Why is this significant? The data gathered at this site indicates that this bone bed is not the result of slow accumulation of fossils over time. The bones do not show evidence of weathering, as they would if they had been deposited gradually. Instead, the way the bones are found in the mudstone indicates that the animals first died and decomposed. The bones became disarticulated, meaning that they became separated and were then deposited together in a single catastrophic event. Large bones, such as limb bones from large dinosaurs, sank to the bottom, while smaller bones, such as toe bones and bones from smaller dinosaurs, were deposited near the top of the bone bed.
We were determined, because we were doing taphonomy, which is the study of everything that happens to the animal from the time it's alive until it's been excavated, we wanted to preserve as much data as we could from the ground. So we decided that we would do more than other paleontologists had done up to that point in terms of keeping track of the data. So we developed technology using high-resolution GPS to map the bones. So every time we would uncover a bone, we would take the GPS and map the exact positions of the bone within a half a centimeter or so. Then we took a picture of the bone, and using GIS software, we integrated the picture with the actual points. So we were able then to recover all the data and reconstruct the quarry the way the bones actually looked in the ground in the computer. So we could put everything back together and get a picture of the bones in the ground, which allows me as a taphonomist to do experiments in the laboratory with these relationships between bones.
Some especially interesting finds include some very rare bones from Nanotyrannus and one of the largest Edmontosaurus femurs ever discovered in North America. Bones with tooth marks and a furculum or wishbone from small raptor have also been discovered.
When June is over and the Dinosaur Project participants return to their homes, the work does not stop. Year-round research continues on the carefully preserved fossil remains, and special computer software is used to create 3D images of each bone. But we're getting ahead of our story.
One aspect of the Dino Dig that makes it unique is the state-of-the-art technology that is now used here. But that isn't how it started. Following the method traditionally used by vertebrate paleontologists, a professional surveyor set marker points in concrete at the dig site. Using these points, string was set up around the site and the position of each bone was determined by measuring the distance from the string.
In the third year of the Dinosaur Project, Dr. Larry Turner, an astrophysicist familiar with space-age technology, suggested that GPS would be a better method to use for mapping the bone bed.
In 2000, the use of GPS technology at a paleontology dig site was first pioneered at Hansen Research Station. Now, once a bone has been excavated and carefully logged, a GPS survey team brings a GPS rover to the quarry and records a number of data points on the surface of the bone. These points capture each fossil's orientation and position in three-dimensional space with an accuracy of less than 1/4 of an inch. The fossil is then photographed and packaged for transport to the paleontology lab at Southwestern Adventist University, where it will be prepped and re-photographed for 3D viewing.
GIS, Geographical Information System, is then used to reconstruct the quarries in 3D. In this way, scientists can see just how the bones lay in the ground, but without the surrounding soil and rocks. Individual bones in the quarries may also be viewed in 3D from any angle.
This online 3D quarry and a web-based catalog of recovered fossils make the scientific data from Hansen Research Station accessible to paleontologists from anywhere around the world.
In 2004, Dr. Chadwick and Dr. Turner were invited to an archaeological dig in Jordan, where they helped extend the techniques developed at the Dinosaur Project to the field of archaeology.
This groundbreaking technique has been presented in papers and posters at meetings of the Society of Vertebrate Paleontology and the Geological Society of America. It is now being used by archaeologists and paleontologists from around the world.
As creationists, we're often looked upon as people that don't do good science. So we were challenged to be innovative and creative and to come up with ways of doing science that would make this a very successful project.
Although the evolutionary paleontologists stated that real science would never be done here again, the Dinosaur Project has actually set a new standard of excellence in fossil fieldwork. Much has been learned here in the fields of geology, taphonomy, and paleontology. Some interesting discoveries about the stratigraphy and sedimentology of the Lance Formation have also been made. In addition, the state-of-the-art technology developed here is now becoming a standard in the field for paleontologic research.